Welcome back, and let's move and try to do one more QA. What we want to do? For each director, we want to compute the total number of movies that the director directed, and among them, what is the number of movies that have received a rating. We also want to compute the average and standard deviation of these ratings, together with the minimum and maximum values for each director. We also want to rank the results in descending order of the ratings, and we want to limit the results to only directors that have directed at least 40 movies, with at least 30 of them being rated. So, how do we approach this query? First, we identify the tables that we need. Obviously, we are going to need the director table because this is from where we'll get the details for the director. We also need the movies table as the rating information is there, and since we want to connect these two tables, we'll need the bridge table movies director. So let's start first by doing the joins. So we type select star from directors D, inner join movies directors MD on MD.directorID is equal to D.ID, and another inner join movies M on M.ID is equal to MD.movieID. Now we have written the query, we have the tables that we need, and the query is showing the directors and their movies. What we want to do now is we want to compute aggregate functions broken down by director. Since the unique identifier for each director is D.ID, we'll define our groups using this value, so we add in the query at the end group by D.ID, which specifies that all our groups will be based on the ID of the director. Notice one thing here, I added the prefix D.ID in the query. Why did I do that? If I don't do that, we're going to have a problem because this join query also has an ID attribute that comes from the movies table. So without the table prefix, SQL is going to complain, asking what is this ID? Is this the one coming from directors or is the one that comes from movies? Now, once we add the group by, remember we cannot have a select star anymore, so we need to replace it with the grouping attribute and the aggregation functions. So we go and we add select D.ID, and now we're going to add the aggregates. So let's start by counting the movies and the rated movies for each director. So we add count star as number movies, comma, count m.rank as rated movies. So let's execute this query, and we'll see that we get back for each director ID the number of movies for the director and the number of rated movies that they directed. You'll see that we have quite a few directors. We have directed just one movie, and quite a few of them actually have no movies that have been rated. We want to make our query a little bit more informative, so we're going to limit now our results only to contain directors that direct at least 40 movies and at least 30 of them being rated. A common mistake for beginners at this stage is you want to limit the results, so people go and write this condition as part of the where clause. So people would write where count star greater than 40 and count m.rank greater than 30. And this will not work. If you try it, SQL will give you back an error. Why? Remember, the where is only being used to filter based on attributes from individual tables. It cannot be used to filter based on the results of aggregate functions. Since we want to filter the results based on the values of count star, the number of movies, and count mrank, the number of rated movies, we need to use the halving clause. So the halving clause goes under group by. We go now in the query, and after group by, we add the corresponding halving clause, and we write halving num underscore movies greater than or equal to 40 and rated movies greater than or equal to 30. Notice what I did in this query. I'm using the alias num movies and the alias rated movies to write the inequality, and I'm writing num movies greater than or equal to 40 and rated movies greater than or equal to 30 instead of repeating the count star and count mrank aggregates here. It's actually possible to do that. Now our query becomes select d.id, count star as number of movies, count m.rank as rated movies, and then we have our join in the from clause from directors d, inner join movies director md on did is equal to md director id, inner join movies m on mid is equal to md movie id, and then we have our group by d.id. We define our groups based on director id, and we limit the results using the having clause, having number of movies greater than or equal to 40 and rated movies greater than or equal to 30. We execute, and now we have the director ID and the number of movies for the directors that direct enough movies. So when we are grouping using the primary key of a particular table, we want. So we go and add round average m.rank, 2 as average rating, the standard deviation round stdev m.rank, 2 as std rating, minimum and maximum, again the mean and the max. So now we execute, and we get back for each director ID the statistics about not only the number of movies that they directed and how many of these movies are rated, but also their average rating, the standard deviation, mean and max values. You'll see that this query is missing one thing. We don't have the first and last names of the director, so we can go now and add the first and last name of the director in the select statement. So we go and add after d.id, d.first name, d.last name. And if we execute this query now, we get back the results having not only the director ID, but also the first and last name of the director. I want now to highlight one thing about what we just did. Typically, whenever we are writing a group by query, whenever we have attributes, all the individual attributes that we want to put in the select clause, for example, in this case, we put first name, last name, and ID. Typically, we also need to put this to appear in the group by. You'll notice that this doesn't happen here. We added first name and last name without adding this in the group by. This is an exception because of the following reason. We can add first name and last name because we group by director ID, d.id in particular, which is the primary key for the directors table. And therefore, when we know the director ID, the values of the first name and last name are by definition always the same. So when we are grouping using the primary key of a particular table, we can also include the attributes from the table without having to add these attributes in the group by. By the way, this is called a functional dependency, and we don't really spend time talking about this concept in this class, but you might run into this terminology if you read additional material on this topic. So we have our query. Now finally we can rank this director. For example, we can rank using the average rating. For example, order by average rating descending. We can also use some other aggregate results. So for example, we can rank based on the minimum rating to find directors that created enough movies, but none of these movies is really bad. So you can order by mean rating descending. If you take a look at the results of this query, you will see that Carol Rysopoulos is a pretty good director, also has minimum rating that is pretty good. And you'll also see directors like Anatoly Litvak, who also has high minimum rating, although his average rating is not as high as others. In our query, you'll see that we had a three-table join, a group by, a having clause, many aggregate functions, and we ranked the results using the results of an aggregate. And also remember about the trick in the group by where we added additional attributes in a table without including these attributes in the group by. Remember, this happens only when we are grouping by using a primary key of a table. In our next video, we're going to do one more integrating example like that. Until then, play around and practice. See you next time.